Welcome to 2023, everyone, and it's just such a pleasure to see you, as always, grouped together to learn about new stuff. And here is some old stuff that I'm sure you've looked at before. If you were to keep generating that first list of numbers, what would you do, and how would you keep on filling it in? 12 would be next. How did you know this? 14. How do you know this? You used your calculator. I hope not. So what's the rule for this sequence of numbers here? You're adding 2 each time. Very good. So you're already able to look at these and recognize what we call an arithmetic sequence. How about this one here? What's the rule that governs this one? Oh, that's right. All right, I like it. This one, we're not adding 2 each time. We're adding a factor 2 each time by multiplication. We're multiplying by 2 each time. So these are not called arithmetic sequences. They're called geometric sequences. All right. So what's our next one? You said 96? Good. And then what's after 96? And et cetera, et cetera. All right. What if I asked you to find the 10th term or even the 100th term? How would we do this? How would we do it? Do we do it by taking a look at some examples and going forward? Let's do that. Let's go. So we're looking at arithmetic and geometric sequences today. Let's keep going. So these are the two types, the two nice types of sequences that you will encounter today, arithmetic ones and geometric ones. Let me highlight some of the important vocabulary for you. You might jot down a definition if you want. Arithmetic sequences, we get that by adding a common difference over and over again, either adding or subtracting. We'll do that. A common difference. And what's a term in these sequences? Well, we looked at 2, 4, 6, 8. So here, we call this term 1, term 2, term 3, term 4, and so on. And we number those just with the letter T to indicate term, and then a little subscript number to say that. In this case, the common difference is adding 2 each time. The common difference is positive 2 for that arithmetic sequence. Okay? The first term also happens to be 2. It's just a coincidence. It doesn't have to be that way. Okay, geometric sequences, on the other hand, progress by multiplying a common ratio between consecutive terms. And since multiplying is just the flip side of dividing, you could also think of this as dividing. If you had a one that went 9, 3, 1, 1/3, well, there you're dividing by 3 each time or multiplying by a third. Same thing. Okay, so these progress by multiplying by a common ratio. So we're going to talk about common difference and common ratio for these. And you want to have an idea of what that is. Okay, so this here in the box, you want to get this onto your page. We're going to be using this. This is the general formula for an arithmetic sequence. The nth term is given by this, where the first term is A, and the common difference is expressed as D. So T1 here is just equal to A, and the common difference is D. So let's take a look at, let's do a little bit of a different one. Just going to change the example from the beginning. 3, 5, 7, 9, 11. Find for me T1, T10, and T100. How would we do this? Well, let's take a look. Here's T1. The first term is 3. T2 is 5. So if I want to find the difference D, in this case, D is going to be equal to T2 minus T1. Right? So in this case, D, the common difference, is going to be 5 minus 3. Also notice, I could have done T3 minus T2 or T4 minus T3. Doesn't matter which term I use. or which two, there's so long as they're right next to each other, the common difference should be the same. That's the definition of an arithmetic series. So D here is 2, A is T1, so A equals 3, and then I can get from my general term what the general term looks like here. So Tn is going to be equal to A, so that's 3, plus the number of term minus 1. Sorry, what was that? Yeah, T1 is just A. A is your initial value. Yeah. Remember how A was the initial value for exponential functions? Yeah. So it's the same here for these. We use the same letter A for initial value or first term. First term T1 is equal to A. Okay. So 3 plus n plus 1 times 2. Okay. I got the D there, and I just put that in, and I get the A over here, and I just put that in to give me my function there. Sorry, not my function, my general term. This is the general term for this arithmetic series. If I want to find T10, I'll just plug that in here for n. So it's going to look like this. T10 is equal to 3 plus 10 minus 1 times 2, and that's going to be T10 is equal to 3 plus 10 minus 1 is 9. 9 times 2 is 18. So my T10 is going to be 21. T10 is equal to 21. And this shouldn't surprise us at any point. If I want to find the 10th term, I need to add this common difference 9 times to the first term. Make those types of logical connections for yourself to see where these formulas come from. Then you don't have to memorize them. You could just recreate them based on what you're seeing here. Huh? Can I just do that? Yeah. Here, watch. Let's do term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9, term 10. Okay? And let's break it down that way so we can really understand this situation. My first term was 3. My next term was 5, and there's commas between them. The next one was 7. The next one was 9. The next one was 11. Let's add 2, 13. Let's add 2, 15. Let's add 2, 17. Let's add 2, 19. Let's add 2, 21. Okay, so there we get to T10 is 21. That didn't surprise us because we already did the algebra this way. And if you take a look at it, I add 2, I add 2, I add 2. I add 2 once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. I add 2 9 times. See it in there? You don't for T10. You could do it in your head, but T100.
Can you just if you know that you start at 3 and you start at 3, you know that you're gonna get. Oh, if you start at 1 and you want to get to T100, you know there's gonna be 99 more after that, right? So can you just do 99 times 2 and then add that to the initial value?
That's exactly what the formula has you doing. So you're saying, why don't I, instead of using the formula, how about I do this other thing, which is exactly the formula? Yeah. It's good. What that means is your intuition is providing the same method that I'm teaching you here that you could just memorize. I don't encourage you to just memorize, but if you like to just memorize, you can just memorize that. But if you want to understand it intuitively, I think that's the road to higher level understanding. So that's good. Yeah. Let's go. Let's use it. So here, let's find A and D for this example, which you have down there. So my A is my first term. So here T1 is minus 4. So A equals minus 4. That was easy. And then D. D equals T2 minus T1. Let's substitute in. Or can you just look at that and tell me what D is? It's not minus 4. It's adding 4. We're adding 4 each time. Add 4. Add 4. So if you can just look at it and you know, then that's fine. But if you don't look at it and just know, you can use T2 minus T1. And that will look like this. 0 minus minus 4. 0 minus minus 4 is the same thing as 0 plus 4 is 4. Okay, so D is 4 and A is minus 4. So here's our general term. Tn is equal to minus 4 plus n minus 1 times D, which is 4. And that's what it would look like. But rather than start there, I encourage you to always, and I just broke my rule here, copy out your formula first. Why should I copy my formulas out every time? How would that help me? Huh? Why would it help me to copy out my formula first every time? It helps me memorize the formula, and I might misremember the formula, and I might not be able to find that if I don't have the formula written down. If I just went ahead and substitute numbers in and there's signs that changed and blah, 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 start with your formula every time, like this. And then substitute in. Here, cool. So then it says write the next four terms. Well, here's the first four, minus 4, 0, 4, 8. And to complete this task, I really don't need this formula here, but I can use it to check my work. Let's just add 4 is 12, add 4 is 16, add 4 is 20, add 4 is 24. No problem. Now this here, that would be the 1, 2, 3, 4, 5, 6, 7, 8th term. So that's like T8 is 24. Let's go ahead and check that. T8 should be equal to minus 4 plus 8 minus 1 times 4. 8 minus 1 is 7. 7 times 4 is 28. 28 plus minus 4 is 24. So you can check that with some quick mental math. See that that's the same thing and say, okay, we didn't make any mistakes expanding that. Hooray. Carry on. Keep going, right? Yeah, Raph wants a faster paced lesson. All right. Now we have another sequence. What's my A value?
Oh, it's 6.
Well, minus 13 is our A, our initial value.
Yeah.
And then our common difference, D, is in this case minus 6. We could do that with minus 19 minus 13, and that would give us the difference, T2 minus T1, and that will also be minus 6. They're getting 6 smaller each time. So let's write a formula for the general term. Here's my general formula for arithmetic sequences, A plus n minus 1 times D. In this case, we have specifically this Tn is minus 13 plus n minus 1 times D. Well, D is minus 6. Why did I put that minus 6 in brackets? Yeah, we're multiplying by D. So you have to remember those brackets because you want to multiply. If I don't have brackets there, it looks like subtraction, and that's wrong. Multiply. Okay, now let's find the 15th term. But it's a good idea to start with a guess. Always start with a guess. Here, I know that these types of sequences make lines if you graph them. They're a line of points. They're not a continuous line because they're isolated points. It's like x is of the integers or n is of the integers here. And it's going down. It's going down pretty fast. So I'm predicting somewhere around minus 100. Let's find out what it is. T at 15 equals minus 13 plus 15 minus 1 times minus 6. Isn't this a delightful mental math puzzle? Let's do it.
14. 14 times 6. 14 times, well, 10 times 6 is 60. 4 times 6 is negative 4. I don't know.
Your calculator will tell you it's negative 97, right? Yeah. So there you go.
I got it wrong.
So the 15th term is minus 97. You probably didn't do minus 13 as well.
You're just waiting.
Yeah. You get your minus 84. Maybe you write it down, minus 13, minus 84, and then you do that minus
I
97.
got 103, which is just one more. Where do you think I went wrong?
You probably didn't subtract 1.
Oh no, I just without the formula I got 103. Like I just did it in my head, so I did like.
You probably did 15
I did
times
neg-
minus
I did-
6.
Oh, am I supposed to do that?
Isn't it useful to have a formula to check against your intuition? Yeah, you want to have two ways of doing these things.
The 15th term counts as 13.
Here is another problem type I might ask you about on Friday, all right? So these ones tell me the number of terms in this sequence. So in this case, my A is 3. My D common difference is, well, I'm adding 3 every time. No problem. 6 minus 3, 3. 9 minus 6, 3. Any one of them is going to be next to one another. Just add 3. So I can use that to get my general term. Tn is equal to A plus n minus 1 times D. There's my general formula. I know that Tn is equal to 3 plus n minus 1 times 3. And now, how will I figure out which term that one is? Plug that in for Tn. Yeah. The nth term is 756. So we're going to say Tn equals 756. And we just want to know which number of term that is. So plug it in. 756 is equal to 3 plus n minus 1 times 3. Now this is a little bit like the Cosmo magazine survey of what kind of solver are you. How do you solve that for n?
You do a little bit of rearranging.
But how do you do your rearranging?
You're go to the brackets first, and then you just do. Well, you times it by 3. I don't know. Well, first you multiply by 3. Do you do 3n minus 3? Is that a thing?
10 minus 1?
Oh, just divide by 1.
Oh,
200.
Yeah. Oh, so you're gonna simplify that side. Yeah, so two different ways you could do this here. Both are fine. One is simplify first, or the other one is just go straight into inverse operations. I'll show inverse operations. So what I would do here is I say, well, n is hidden inside layers of armor. It's inside a bracket. It's having subtraction done to it inside the bracket. It's being multiplied outside the bracket, and then it's being added to outside the bracket. I'm going to work in inverse Bedness order and clean everything up. So my first step is going to be to subtract 3 from both sides. I can do that in my head and get 753. 753 equals 3 multiplied by n minus 1. Okay, that's just this, comes down. Okay. And then I can divide both sides by 3. Sure. Divide both sides by 3. 753 divided by 3 is 251. Use these as mental math puzzles if you can. It's good to work your mental math muscles. 251 equals n minus 1. And then here add 1 to both sides to clean that up. N equals 252. 252. Yeah. So therefore, 756 is the 252nd term of this arithmetic sequence. But like Isaac was saying, this is begging to be tidied up. Let's just simplify that. We can express t of n more simply. And then you'll see that it's quite obvious. Tn is equal to 3 plus 3n minus 3. That's just expanding this 3 into this bracket. So Tn is equal to 3n. And this is still an arithmetic sequence. It's just been simplified so that if I put in 1 for n, I get the first term. If I put in 2 for n, that's just 3 times 2, 3 times 3, and so on. That's 3 times some number. Divide that by 3 and you have your answer. It's 252. I know, it's very exciting stuff. Now we get into, these are a little more fun. Geometric sequences. So with geometric sequences, we also want to have a general term. Our general term here for t of n means the nth term of a geometric sequence. It's going to look like this, where a is the first term, or our initial value. That's just the first term, t of 1. And r is the common ratio. How do we find the common ratio? Well, if we take a look at here, just going to go down here, give me some space. R is the common ratio. Let's look at this one again. 3, 6, 12, 24, dot, dot, dot. This is from the first slide. Okay. I know that A is equal to 3. That's my starting one. I can see that I'm multiplying by 2 each time, but let's say I don't see that. Some of them you're going to need a mechanical way to find these. They're going to be weird decimals or things like that. Could be pi, could be the golden ratio, who knows. So what you do is you could do T2, that's a 2, T2 divided by T1. And that will be 6 divided by 3 is equal to 2. So there is my R. That's R, the common ratio. But I can also, the astute among you will also notice T3 divided by T2, well, that's 12 divided by 6. That's also 2. And that's how you test to see is this thing a geometric sequence or not? Is the ratio common to all of these terms? It is a common ratio in this case, so that's our general term. In this one, Tn is equal to 3 multiplied by 2 raised to the power n minus 1. And I like to put that n minus 1 in brackets just to remind myself. Do that first. Common ratio. What common ratio? What geometric sequence?
Sequence of numbers.
Well, this is your general term here, and this is the formula that you're going to be using. N minus 1 is, you can see.
It was a while
Yeah.
ago.
Yeah. It's a sequence of numbers which are which have a common ratio between all of them. I guess.
Consecutive terms.
Be related by that common ratio or something like that. All right, let's carry on to some examples. So sometimes you'll have to solve for A and solve for R. In this case, solve for A is not hard. 4 is equal to A. You just look at the first term. And then R, well, that's just equal to, T2 divided by T1, which in this case is 12 divided by 4 is 3. Let's test. It should also be equal to T3 divided by T2. Well, that's 36 divided by 12. Oh, that's also 3. So 3 is the common ratio. So in this case, Tn, the general term, would be 4 multiplied by 3 raised to the power n minus 1. Okay, cool. So now what's next then, eh? What's next then, eh, is to say what are the next 4 terms? Well, with questions like these, you can just keep multiplying by 3. Like 36 times 3, do it in your head. 108 times 3, do it in your head. 324 times 3, do it in your head.
972.
Good. And we wanted one more. So do 972 times 3 in your head.
2007.
No. What's
Okay, a
9 times
little
3?
north
Plus
of that.
210.
2,916. 2,916.
Oh, yeah, that was a trick.
Right? Cool. So that's all we need to do. Yeah. But you can also test, did we make any mistakes using our formula there? You could also, and you'll find that it's true. Okay, so this, well, let's keep going. All right, solve for n. Solve for t of n. Okay, so here we have our sequence 1, 2, 4, 8. Oh, I know this one. It would be 16, 32, 64, etc. And we want to solve for the 15th term, not the 32nd term, the 15th term. So let's find that. First, let's write the formula for the general term. A is equal to 1 and R is equal to 2. I can just see it's doubling every time. I'm not going to divide them. But if I did, I'd find that there was 2. Okay. So my general term, Tn, is equal to 1. Well, I'm going to write it out. A R to the n minus 1. Okay. So in this case, it's 1, so I don't write anything. 2 raised to the power n minus 1. That's my general term. The nth term is 2 to the n minus 1. That's it. Now, we've been asked to find the 15th term. So let's go. T15, well, that's going to be equal to 2 to the 15 minus 1.
2 of 14.
2 to the 14. It's hard to do that in your head,
Wait.
so use some kind of counter.
Okay. 2, 4, I know what. 16.
Or use a calculator.
108. 16 times 4, 108. Oh, what did I say? What am I saying? Wait, give me a guess. What do you think?
I just did that.
Oh, you know. You think you could have gotten that, Michigan?
Yeah, but you don't want to watch me count that far. 16,384. And I might make a mistake, and then everyone will laugh at me. 16,384. There. And so that's the 15th term of this geometric sequence. See, they grow pretty quick, eh?
Can you draw these?
Yeah, you can graph them. They follow exponential functions.
Oh, yeah.
They are exponential functions. You look at this, and it's just an exponential function.
Yeah, so that
But the thing is, n is of the integers. Right? We're not looking at real numbers. We're not looking at smooth curves. We're looking at a series of points. That's the difference here. Okay, and then what if I ask you to tell me what number term that is? 2, 9, 16.
7 for TN.
Yeah.
So you go like.
In the morning they noticed that we'd already done this, but let's see. Let's do it. My Tn is going to be equal to a multiplied by r to the n minus 1. I see that a is 4. And my common ratio is multiply by 3. So I'm going to put those in here. Tn is equal to 4 multiplied by 3 to the n minus 1. Okay, now we know that 2, 9, 16 is T of n. We just need to find n. What number term is that? So sub it in here for T of n. 29, 16 equals 4 multiplied by 3 raised to the power n minus 1.
So can you divide by 4 first?
Absolutely. Take away that 4 by division and do that in your head. 29, 16. So 4 goes into 29 7 times, leaves 1 remainder. Right? So it's going to be a 7. It's going to be 700 some. 4 goes into 11 twice, leaves 3 remainder.
700, 458.
729.
Wait, how?
Oh, yeah.
Because 4 goes into 11 twice with 3 remainder.
Oh, it's
And then the 3 remainder with the 6 makes 36. 4 goes into 36 9 times. Oh, look at that. 729 is a power of 3. So that's 3 to the n minus 1. You can solve this by changing the base. So if you remember that 729 is 3 to the 6, then you go from there to say 6 equals n minus 1 and 7 equals, I'm this fancy math guy that remembers my powers of 3 up to 729.
Wait, what? Whoa. So to get rid of the 3, what do you do?
Yeah.
Which,
Oh, no.
3 to the 6 is the same thing as 3 to the n minus 1.
Yeah.
So now I equate the exponents. N minus 1 must be 6.
Oh, yeah, you just get rid of
Remember that bit?
Yeah, you just
Yeah.
get rid of the base.
Yeah, like the base is like now no longer necessary in our calculations. We're just looking at how many times did we need to multiply by 3 to go from that to 4 up to 2, 9, 16, whatever it was.
That's crazy. That's wild. That's something. How do you think of that?
Now, 7 equals n. Let's go back up here and check. Oh, there is this sequence. Look at it. There's the same one. And there's 2, 9, 16. 1, 2, 3, 4, 5, 6, 7. Oh, it works.
How'd you come up with this stuff?
Actually, I did not make this this sheet. This sheet was made by Miss Metherall's. I use a lot of Miss Metherall's stuff.
She's got crazy handwriting.
Yeah. So there you go. That's the new topic. Try these problems.
Yeah, man.
And I'm gonna come around. I got lots of stuff to hand back to people. Thanks, man. And if your team learn at home, send me an email with your questions. Bye for now.